I'm just looking for something very rough. So my first example here is y is equal to negative 5x squared. Negative 5x squared plus 10. So looking at my graph, what is my vertex in this parabola? What is my vertex? Jade. And what? What's the y value? 0 and 10. So my vertex is going to be 0 and 10. So when I sketch this out, that's going to be the important information I have. So again, this is a rough sketch. So this is 0 and 10, and that is called my vertex. And which way did the graph open or is going? Which way? Going down. So my rough sketch going down. And because it's a sketch, I need to include my arrows. So the domain, again, has to do with my x values. So in this case, if I were to look at this graph, because it's continuous, does it exist in all of the values of x, or is there a certain limit that it reaches? Let's see. It's that weird notation. Does this graph exist on all of the values of x, or is there a maximum limit that it reaches? Remember, the arrows mean it's continuous forever. So would it exist in every single number on the x-axis, or is there a limit to it? Someone said it? Yep, it would exist in every single x value, okay? Because it's continuous and there are no restrictions at the graph. So for every parabola, the domain is always going to be written like this. So I can write d, fancy brackets, x is an element of all of the real numbers, okay? Because if I look at my graph on Desmos, if I go on this point over here, if I take this one, I keep going, as you can see, it continues for every single value of x. And if I zoom out of this graph and I continue going down, as you can see, all of my x values keep getting bigger. And as you can see, there's no end in sight with this parabola, which means that my x values are every number in the real number system. However, if you guys notice with the y values, which is my range, what do you guys notice about this graph? Look at the vertex. We said it was 0 and 10. If we look at the rest of the graph, what do my y values have to be? Anyone have any idea? So because my graph is opening down, that means it has a maximum value of 10. Does my graph go up? Does it hit y equals 11? Does it hit y equals 12? No. Because it doesn't go anything above 10, that means 10 is the maximum y value that it can hit, which means that all of my y values have to be less than or equal to 10. So your domain, or your range, sorry, depends on your vertex. So this depends on vertex, and it also depends on how the graph opens. So when you write your range, we're going to write, again, YER, and then this vertical line means that there is a restriction. In this case, because my graph cannot go over 10, my y values have to be less than or equal to 10. I'll zoom in on this. So as you can see here, 10 is my biggest y value, which means everything else is going to be less than 10. So the domain for all of these is going to be the same. Even for lines, your domain is always going to be XER. So parabolas and linear relations are always going to have the same domain. So you guys can actually already fill out that domain column and put D as XER. Yep, Brooklyn? So it means X is an element of any real number. So as you can see, when I go on Desmos, for every X value, it gives me a Y value, right? So for example, if I take this line, so at 0.7, my Y value is 8 point something. If I keep going down at 0.72, my Y value is 7 point something. So for every, so X is existent in all of the real numbers on that X-axis. Do you guys remember what a real number is? 1.2, 1.4, 1.3, 1.66, 1.875. It's basically all the numbers you can think of in the number system. Yep, Rita?
Well, there's like the F in the bracket X in the beginning.
The brackets?
No, like, where it's in the function,
Mm-hmm.
when it says like F bracket X equals -5.
Oh, so f of x, so we'll actually learn about that after. So today's just domain and range. F of x means a function in terms of x.
Oh,
Okay, so if I want to find the y value, if I want to find the output of my function at x is equal to 5, you know how do you have that x in the bracket?
yeah.
If you want to find at x equals to 5, you put f at 5. So f bracket 5, and then you plug in 5 for x. Any questions so far? You guys may be a bit confused, but now that you know that linear and parabolas have all the same domain, we can actually fill out all of that already. So this one's going to be XER. And then the third one's going to be XER. Yes, Annabella?
If it's like all real numbers, then why would it not be like domain XER?
For example, you remember the in the first lesson where we had like 1 and 2 bracket 3 and 4. If it gives you a set of if it gives you a scatter plot or a set of coordinates, then you would write domain is equal to those numbers. But when it comes to functions, because functions are existent in all of the x values, that's why most functions have a domain of XER. When it's not a function, then it starts becoming a bit more difficult. So the first three you can fill in as XER. So R means real numbers. So remember, R means real numbers, so don't get freaked out. Okay, so we'll do another example with the next one. Then you guys get to see why the domain is always XER and why your range depends on the way your graph opens and the vertex. So if I go back to Desmos, I can get rid of this. So y is equal to 3 brackets x minus 2 squared plus 3. Okay. So if you guys notice here, where is my vertex? Let me just, where is my vertex? What is this point? 2 and 3. So my vertex is 2 and 3, and my graph is opening up. So when I sketch my graph, my vertex is going to be right over here. And my graph opens up. So as you can see, my domain is still XER because my graph is continuous throughout all the x values. but can one of you or some of you tell me what my range is going to be? And see if you guys start to notice the pattern. So you always start with YER and then your restriction. Rita.
YER, the restriction would be anything that's less than 3.
Oh, which way is my graph going though?
Oh, I mean, more than.
Yeah. So my y has to be bigger than or equal to 3. Because as you can see here, the lowest y value that it can go is 3. And after 3, it gets bigger. So is my vertex a maximum or a minimum point? No, remember it's at the bottom. Yeah, minimum. So this is a minimum, and my first one was a what? Yep. The first one is the max point because that's the highest the parabola goes. And my second one is a minimum because that's the lowest y value that my graph hits, which means every other y value has to be bigger than or equal to 3. I'll do a couple more examples at the bottom. Actually, I'll give you guys one right now after we do the next one. I'll give you guys one. Okay, so if you guys look at the third equation, is that a linear or a quadratic equation in the third one? Linear. So my linear is still going to be XER as my domain, but what do you guys think the range is going to be? Is there a maximum point? Is there a minimum point? What do you think it's going to be? So this is my graph. Does it have a maximum or a low y value? So what would my range be? Does it exist in all the y values? Look, it keeps going. So with a line, just like my domain, the range of a line is going to be YER because there's no maximum y value and there's no minimum y value. Because my line is continuous basically forever until infinity and negative infinity. So my graph, like I drew it out, so I have my x and my y-axis. This is my line. And it's continuous going into the positive y values and continuous going into the negative y values, which means that it exists in every single point on the graph. Any questions or confusion so far? of my own. I'm not going to write the equation because there's going to be no need to. So this is an extra example. So find domain and range. So on this graph, I'm just going to give you my vertex. So I have my X and Y axis. My vertex is going to be at 3 and 19. And it's going to be opening downwards. So who can tell me what my domain is? What is the domain for every parabola? Rita. And now let's see if you guys can come up with the range based off the vertex that I have. Abigail?
19 equals 19 and under, I think.
Yep. So you'd write y is less than or equal to 19. Can someone tell me why I use the inequality less than and equals to or greater than and equals to instead of just less than? Sarah. Yep. The reason why I use the equals to is because it actually hits the y value of 19. If it didn't hit the y value of 19, it would just be less than. But because the vertex always hits that specific point, that's why we use the inequality greater than or equal to and less than or equal to. We never use this guy unless we're talking about other functions, which we will get to probably tomorrow. So don't use yet. Okay, so take a couple of moments to copy that down. Yep, Rita? So because it's the highest point, it's the max. Okay. So you guys starting to understand this better now? It's pretty good. Just remember, your range is the most important part because it depends on your vertex and which way the graph goes. Andrew, you don't have the sheets I gave you? I gave you them. Oh my God. Okay, let me know when I can scroll up. All right. I'm going to scroll up. You're good? Okay. So now we're going to get into some graphs that are not real. Some may be functions, some may not be functions. So I have the graph y is equal to 5. Now, based off your experience with grade 9, grade 10, is this going to be a horizontal or vertical line? Let's see if you guys remember. It's going to be horizontal. So I get y is equal to 5. So y is equal to 5 is a horizontal line. Now I'm going to draw my graph, my axis. So this is 5. And this is my graph. Okay. So what is my domain for y is equal to 5? What is my domain? Let's see if you guys can figure this one out. Paulina? not x equal to 0. So this is 1, 2, 3, 4, 5, 6. Does it continue on all of the x values? So what is it? Yep, XCR. Now, the range should be easy to see. What is my range? It's not YER in this case. Nope. What number am I going to put in that bracket? What is my only Y value that this hits? 5. 5. The reason, Ashton, why it's not YER is because it never hits 5.1 or 5.2. It just only hits 5, which is why my range is just going to be 5. So the next one, now you guys can do that process of elimination. X is equal to -2. What kind of line is that? Vertical. So I get X is equal to -2. That is a, what is this mean? Why is it? What is this? So this is X is equal to -2. It's a vertical line. So again, I'm going to draw my graph. This is my X value -2. And my graph is just literally a vertical line going up and down. Now, what do you guys think my domain is going to be? Camilla? Pardon? -2. So my domain is just going to be the X value that it hits, which is -2. Now, if you guys notice the pattern between a horizontal and a vertical line, what is my range going to be in this case? YER, because my graph can continue going all the way up, and it can continue going all the way down, which is why my range is all of the real numbers in the y-axis. So is domain and range difficult, or it's pretty easy? How many of your friends cried during their 11U quiz on Friday? A lot of them?
Yeah, they also should like school.
Oh,
They're all like school.
all of them? I'm not teaching that, so it's not my problem.
Yeah, they need it as a free.
The only thing I'm teaching in high school is calculus. That's what I teach. Well, like I said, this is going to be the last year that's going to be good for night school because it's all online. I think after this year, they're going to start going back in person to night school. So this is the last good year to get an easy mark in night school. Okay. And last but not least, I have coordinates. So I'm going to draw my X and my Y axis. That's a terrible line. So here I'm going to plot my certain points. So this is actually, you're not going to connect the points. And why are you not going to connect the points? Does anyone know? What type of graph is this when you have just random points given to you? It starts with an S. It's a scatter plot. This is a scatter plot. So my first scatter plot point is going to be 2 and 3. My second scatter plot point is going to be 6 and 8. So this is going to be 6 and 8. And my last scatter plot point is going to be -4 and 5. So when you're doing domain and range for scatter plots, you're just looking at all of the x values and making them as a list, and same with the y values. So what would my domain be for the scatter plot? What are the x values that we have here? If you look at the coordinates, Abigail? So -4, 2, and 6. So remember to just write them in order. And then I have my range. So my range has to do with my y values. So what are the y values that the scatter plot hits, Jade? 3, 5, and 8. So when it comes to scatter plots and coordinates that are given to you, you're just writing your domain and range as a list of numbers, okay? Because there's no in between. They're just specific points, and those are the points that just exist. And remember, don't make the mistake of connecting your lines with scatter plot, because it's not supposed to be done like that. Scatter plots more for data collection than they are actual graphs, so hence why you don't really connect the points. Okay. And then we're going to go to the dreaded word problems that everyone dislikes in math, because some of us don't like to read. I'm one of those people. I skim through the question and I miss some points. So we have our word problem. So again, we are going to create a table of values with this one, but I need to figure out how this graph actually looks like. So the following function represents the height of the ball being thrown out of a window where time is t in seconds. So the expression or the equation is h of t is equal to -5t squared plus 5t plus 30. We want to use a table of values to make a sketch. We're not going to make a sketch. We're not going to do a table of values. We're just going to use Desmos. So use Desmos. We're only going to be using it now, but later on you guys will be using a table of values. So I got y is equal to -5t squared or 5x squared plus 5x plus 30. So my vertex is going to be this point over here. So can someone read that? What's my vertex of this graph? Rita?
Is that 0.5?
Yep.
31.5?
Yep. So my graph is going to look like this. So this is my vertex. It's 0.5 and 31.25, I hope. Yep. Now the other important thing to figure out are my x-intercepts. So we have it at +3 and 0. And we have the other one at -2 and 0. So now I can draw my graph. Okay. So this is my vertex. So for A, how many seconds is the ball in the air? So my x-axis is my seconds, and my y-axis is my height. So remember, guys, because this is talking about time, does my negative x-axis count in this case? Can we have negative time? No. So this part of the graph over here, you can completely disregard it. So this, you don't have to worry about. So how many seconds based off of this graph was the ball in the air for? Ashton?
What are the coordinates on the right?
3 and 0. So how many seconds was the ball in the air for? 3 seconds. Okay, what is the maximum height of the ball? We kind of figured that out already with my Vertex. What's the maximum height of the ball? Sarah?
31.15.
Yep. What are the units? Oh, should be meters. Meters. It'll be meters. Yeah.
Okay.
31.25 meters. Now this one, the domain and range is going to be a bit tricky. Okay. The reason why the domain is going to be more tricky is because of the fact that we're working with time. So for my domain and range, we can still write XER. That is always going to be true. Now, because we're dealing with time, what are the times that it's going to be in between, that it has to fall in between? So what's my starting time? So when you start to throw something, how many seconds have gone by? When you start right at the beginning? 0. 0 seconds. And how long was the ball in the air for? 3 seconds. So my domain has to be in between 0 and 3 because that's how long the ball was in the air for. So 0 is my lowest one, and 3 is my maximum. And then you can use your inequalities. So X has to be more than 0 seconds, but it cannot exceed 3 seconds. So you would write it as X is greater than 0 and less than 3. But we have to put the equals to sign because it hits those times. And I'm going to draw them out with a black dot. So this is the lowest time that it can be, 0 seconds. And this is the highest time, or the maximum time that it reaches, 3 seconds. So my graph falls in between 0 and 3. Any questions so far? There might be some confusion right now. You guys understand why the domain has to be between 0 and 3? Okay. Normally, what would my domain be in this case? What would my normal domain be for a parabola? Normally, without these restrictions, XER. But because we're dealing with time, we have to put these restrictions. Now I have my range. So if we look at the range of the graph, so it's going to be YER as usual, and there's going to be a restriction. What is my highest Y value? What's the maximum that it hits? Ashton. What is the lowest Y value that it hits within 0 and 3 seconds? Someone said it. No? 0. Which is this guy over here, because my Y value is going to be 0. You guys can say your answer loud. If you're wrong, I'll tell you you're wrong, and then I'll tell you how to get the correct answer. So your lowest Y value is going to be 0. Now, you're going to do the same thing as we did with my domain. My Y has to be bigger than or equal to 0, whoops, I don't know why I wrote 0 again. But it cannot exceed 31.25. So it has to be less than or equal to 31.25. So because of our restrictions with this question, we have to write it like this. Normally, what would we generally write the range as in this case without the restrictions? Or my range of this graph? Other way.
Less than.
Yep. So this is because of our restrictions with time. Oh, my. However, normally, our range would be, as Sarah said, YER, such that Y is less than or equal to 31.25. So take us a couple seconds to copy that down. Oh, that's right. So any questions about domain and range? So when you are doing the homework, you can use Desmos to graph the function and figure out the domain and range. Don't do the table of values, okay? So use Desmos for your homework. So I'm going to write it down here. Use Desmos for your homework questions, okay? And you guys have the homework questions on the on Google Classroom as a separate document. So do that, and then you guys have, what is it, half an hour to do them. So you can ask me questions during that time. And if you have questions about the homework from before, I can come answer those as well. Tomorrow we'll start the class by taking up the homework from this lesson. Yep. The one from 1.1.